Today we'll talk about limit of a function. So we'll start by definition, then we'll learn one-sided and two-sided um, limit of a function, right? Then we'll talk about limit law of definition. Uh, then we'll practice some example. So let's start with the limit of a function. So suppose that we have a function f of x is defined for all of x values, okay? Near x near to a, okay? Possibly at a, but not at a exactly, x equal not a, okay? If f of x is arbitrarily close to L, right? Let's say it is close to L. It is as close as L, but it's not exactly L, okay? For all x sufficiently close to A, we can write limit x goes to A, f of x equal L. So we say that limit f of x is approaching to L as x is approaching to A, okay? Since x is approaching to A, f of x approaching to L. So it can approach to, let's say x approaching from to A from left side. If it's left side, then it's going to be negative. If x approaching to A from right side, it's going to be a positive, right? If both of them has the same value, as close to value L, then x approaching to A will give us f of x value of equal to L, okay? So let's look at an example that will clarify our view. So let's say for this example, this is our f of x, okay? Now, let's say we say limit x approaching to 8 from left side, from this side. If it's from approaching from the left side, it's going to be negative, right? And so f of x equal, let's say from left side, if it's approaching from left side, from here, we got here, right? This is 7. So this is 7. Then let's say limit x approaching to 8 from right side. So what is f of x? So right side. So it's going to come from here, okay? So that's been from right side here. X approaching to right side, we get is still the same value. F of x equals 7. So it is 7. Since from left side we get x values here, f of x values here 7, and from the right side x approaching to 8, from the right side we get the same values. So our final answer for limit x approaching to 8 f of x is simply 7. That is our answer. So now let's go over with limit laws. So let's start with the sum law. What is sum law state? It states that let's say we have limit x approaching to b f of x, one function, and limit x approaching to b g of x, another function. Both of the function is defined for x of b or exist, right? Then limit x approaching to b f of x plus g of x equal is just simply the sum of those two function, okay? So let's just find out the answer. Let's just do a practice that will give us the clear concept. So let's say we have limit x approaching to 3, f of x equal 5. X approaching to 3, g of x is just 4. So that's when both of them are defined, right? So now we're going to apply here sum law. What is the sum law says? It says that if both of the function is defined, right, for same limit, right, then we can just simply write it down. Limit x approaching to 3 f of x plus limit x approaching to 3 g of x, sum of these two functions, right? So what's the answer? We know this value is simply 5 and this value is simply 4. So you just can just write on 5 plus 4, which is 9. That is our answer. So this is the detailed view, okay? You guys can take a look at it. Now let's do the difference law, right? Limit difference law. So let's say we have again f of x of b is defined and limit x approaching to b g of x is also defined. both of them are exist, that's mean, right? So then the limit x approaching to b f of x minus g of x is just simply the difference between these two functions, right? Let's do an example. Let's say we have the same function what we did for the addition. So now it's going to be simply limit x approaching to 3 f of x minus limit x approaching to 3 g of x. So you just have to simply write down the answer. This is 5, and for this one it is just simply 4 minus 4. So 1, 5 minus 4 is 1. That is our answer. You guys can take a look at it. Here we have the detailed explanation. Now let's do the product law. What is our product law state? It's again, if both of the function is defined right here, limit x approaching to b, here x approaching to b, it is f of x and g of x, both of them defined. Then limit x approaching to b, f of x times g of x is going to be simply the product of these two functions, right? So let's look at an example. Let's say we have this. We are using the same example over and over. So it's going to be simply limit x approaching to 3 f of x times limit x approaching to 3 g of x. Okay. So the value for this one is just simply 5 times the value for this one is just simply 4. 5 times 4 is just 20. That is our answer. This is the detailed view. Okay, now let's find out the quotient law, right? So again, let's say both of the function is defined, and here then x approaching to b f of x over g of x is going to be simply the difference, simply the quotient of this function, right? Since this is our denominator, it cannot be 0. Okay, so let's do an example. We have the same function, right? So if we have it, it's going to be simply limit x approaching to 3 f of x over limit x approaching to 3 g of x. So it's going to be simply, this value is, already 5 over this value is just simply 4. So this is answer 5 over 4. Okay, so this is the detailed view. You guys can take a look at it, the explanation. Now let's learn the power law. What is the power law? It's saying that, let's say limit x approaching to b, f of x is exists, right? That's when it is defined when x approaching to a, and also n is an integer here, and n has to be more than 0. It cannot be negative. Then x approaching to b, f of x n is gonna be simply limit x approaching to b, f of x, the value of it, power n. Okay, so let's do an example. Let's say we have limit x approaching to 3 f of x equal 5 and n equal 2. Then what will be the value for this one? It says limit x approaching to 3 f of x power 2. So we can just simply write down limit x approaching to 3 f of x over power 2. Okay, this power we can just write down like this by the quotient law, by the power law. So the value for this one is just simply 5. So 5 power 2, which is just simply 25. So this is our answer. You guys can take a look at it here. I wrote it down clearly. Now let's learn the root law, right, for the limit. So let's assume that we have the function here, again the same, and n is integer, right, and it has to be more than 0. Then limit x approaching to b, f of x power 1 by n, that's mean the root is going to be simply the value of the function power root. Okay, when x approaching to b, here f of x has to be 0 when x near b is an even number, right? And when n is even number near b and n is even number, f of x has to be 0, because you already know the square root of negative cannot be happen, right? So there's has to be positive when you have square root, when you have even. But if we have square root 3, we can have negative 125, right? That will give us negative 5. But for this one we cannot have a negative for any even root. Okay, So let's do a practice. So let's say we have uh, limit x approaching to 3, f of x equal 25, n is 2. Then compute the following. So we have it, you see this 1 over n. Whenever we see 1 over n, that's mean that's the root, right? So we can just use the root law. So limit x approaching to 3, f of x, and power 1 over n. You see, we can just write down root 1 over n whole for the whole function. So what's the value for this function? It's just simply 25, and our n is just simply 2, so 1 over 2 is 25, right? So this is, we can just write down is a square root. Is power half is just simply the square root, right? So square root of 25 is just 5, so that is our answer. Just, this is the last law. This is called constant law of a limit. Okay, so let's assume that x approaching to b, f of x is exist, right? Also c is a real number. Then limit x approaching to b, c times f of x is going to be simply c times limit x approaching to b, limit f of x. Okay, so let's look at an example here. Limit x approaching to 3, f of x is just 5, right? And if we have now here, c is the constant. So it's just simply we have to take out the c from the limit function. Limit x approaching to 3, f of x. So it's going to be 6 times whatever the value we have. 6 times 5. This is 30. So that will be our answer, okay? Now also, let's say we have function like since x approaching to 3, let's say 8. So this is going to be simply the constant, right? 8 is the simply constant. So the answer is going to be simply just 8, okay? So this is the detailed view of the solution, the example we just did, right? Thank you guys. See you in the next video.